I have questions on tree diagram. Tree diagrams. Now, basically, this is a part of probability wherein what we need to understand is questions of this kind can be branched out as a tree diagram. Let's see and make you understand this thing. See the first question. Here comes a bag contains five red balls, three green balls. A ball is drawn and then replaced before a ball is drawn again. So two balls are drawn one by one, but the first one is replaced. Draw a tree diagram to show all the possible outcomes. Done. Find the probability that is later part. So let's draw the tree diagram first. Now what happens? There's first draw and there's a second draw. So here comes your first draw. Then I draw a vertical line for my understanding, and then comes the second draw. Right. Now here I start with there are two balls, a red and green. So here comes a red ball. Right. So what is the probability of a red in first? R1 means red in first, right? So there are 5 red balls out of total 8. Do you understand this? The probability of first red ball is 5 by 8. I hope that is understood, right? Next comes is a probability of a green ball in the first draw. So that is equal to what? That is equal to 3 by 8. I hope that is clearly understood. Once this is done, now this will branch out into 2 for the next event. Do you understand this? This branches out for 2. In a similar way, this branches out for 2. Right? So this is how we say this is a tree diagram. Okay. Now, again you can have a red. So I write it as P of R2. Red in second draw. P of G2. You can have green also. In a similar way, you can have red and you can have green. Now just understand this. Now, what is the probability? Since the ball is drawn and kept again. So if it is kept again, the bag remains the same. So probability of red again remains the same. It's 5 by 8. Similarly, probability of green remains the same. It's 3 by 8. Probability of red 5 by 8. Probability of green 3 by 8. This is a very easy problem. The very reason being things have been replaced. I highlight this word replaced. Since things are replaced, the second event actually hardly matters. Right? So this is the tree diagram showing all the possibilities. Am I very clear with this? Now, the probability you want to find. Two green balls are drawn. So probability two green balls are drawn is probability green in first and green in second. So green in first and green in second. Right? So probability of G1 into probability of G2. Do you understand this? Clear with this thing? Now probability of G1. Probability of G1 is how much? 3 by 8. What is probability of G2? 3 by 8. So your answer is how much? 9 by 64. I hope the first part is very clear. In a similar way, the second part, just try to understand. The first ball is red and the second is green, right? So first ball is red. Probability first is red, R1, right? And second is green, yani G2. Do you understand this? So that can happen in how many ways? It is P of R1 into P of G2. Do you understand this? You need to define this R1, R2, G1, G2 since you have written it for your reference. There is no standard thing. R1 means red in first, right? Red in first, draw. Right? Similarly, R2 means second draw. Do you understand this? And similarly, G1 means green in first draw. Right? Or I can just say G2 to start with. G2 means green in second draw, right? And G1 means green in first draw. I hope that is understood, right? Okay, here. So P of R1. What is P of R1? P of R1 here is 5 by 8. It does not change. Here it is 5 by 8. I hope that is understood. Into P of G2. P of G2. Take it from anyone, right? Here, see, actually it has to be taken from here. P of R1 into P of G2. So P of G2 here turns out to be how much? It turns out to be 3 by 8. 3 by 8. So finally my answer is 15 by 64. I hope that's clearly understood. So that is how you draw a tree diagram and solve a sum. Now let me go for a tough sums, right? So here, try understanding it. Now since we did one on a replacement, the second is not replaced. Now let's see how do you understand this not replaced. Anything that you don't understand, go back to the video, try understanding it again. Here we have the next part which says what? A bag has 5 red balls, 3 blue and 2 yellow. Right, so here I make a bag for you people to understand. Here you have say a bag, right? A bag with 5 red, 3 blue and 2 yellow. Okay, done. A ball is drawn and not replaced. I have already highlighted, not replaced. A second ball is drawn, then find the probability. So let's first have a tree diagram, right? Now, a tree diagram will have how many branches? 3 branches. Why 3 branches? It is a red, blue and yellow. So here is a red, here is a blue, here is yellow, right? So probability red and 1. Again, first draw. So this is my first draw. There is a line here. I draw a line here. Do you understand this? So probability red in first row. It is 5 reds out of total. Total is how many? 10. I hope that's understood. Next comes as a probability of blue in first row. That is 3 by 10. Done. And probability of yellow in first row. That is how much? 2 by 10. That's clearly understood. I hope that's done. Right? Now once this is done. Okay, this pointers. Here are the pointers. Right? Now again each branch will have 3. 1, 2, 3. Here also 1, 2, 3. Here also again I just draw this thing towards the upper so that I have more space. Here I just erase this part. Okay, done. So here I'll have 1, 2 and 3. Done. Okay, again P of what? R2. Do you understand this? R2. R2. Here you have P of actually this comes into not replace, replace. This comes into conditional probability. But for IGCSE as such, right now since you're not familiar with that particular part, I don't write P of R2 upon R1. So let's not get into this thing because it will just confuse you. Right now make it more simple. P of R2, simple, right? Okay, so here we go ahead with our work, which says again P of R2 done. Next comes as what? Next comes as blue ball. So P of B2 here. Next comes as P of what? P of Y2. Done. Okay, similarly this branch has to be what? This branch has to be same way R2. This branch, okay, this branch has to be B2, and this branch has to be Y2. Here, this particular branch R2, B2 and Y2. I hope that's understood. Why so 2, 2, 2, 2 here? Here this is my second draw. This is my second draw, right? Okay. Now try understanding this. First ball taken. I have taken first ball, that is a red one. I have kept it aside. So one red ball less and one ball total less. So now how many red balls left? 4 red balls left. Out of total how many? 9. I hope that's understood, right? Now since the first ball was a red, how many blue balls are left? Blue ball does not change. They will be 3. 3 by 9. Do you understand this? Why 9? Because one ball is kept aside. It is not replaced. Yellow, the number doesn't change, right? But total number is 9, right? Now a blue ball is taken. So red count doesn't change. The red count has to be 5, but total is 9, right? Blue ball ka count will change. It will be 2 by 9. Do you understand this? Clear? In a similar way, yellow ball count won't change. It will be 2 by 9, right? Red, again, the count won't change. It will be 5 by 9. This time blue count won't change. The reason being first was taken as yellow, right? The first is yellow. So blue ball count won't change. It is 3 by 9. And finally yellow the count will change. It is 1 by 9. I hope that's clearly understood. So that's a tree diagram. Right? Now let's answer this. Find the probability of 2 red balls. Simple, right? I take the first one, right? Probability 2 red balls. So which branch I'm supposed to see? 2 red balls means probability of red 1 and the probability of red 2. So that is P of R1 into P of R2. Do you understand this? Clear? See, guys, understand this is conditional probability, but since you do not have surfaced that thing to that particular topic right now, I'm writing it as P of R2. How do you see this? It has to be R1 branch only. Start with the R1 branch. So R1 branch and then R2 branch. Don't take R2 from anywhere else. It has to be R1 branch first because R1 has taken place and then R2. Do you understand this? So it's 5 by 10 into 4 by 9. I hope that's understood. Clear with the idea? So this can be simplified as 2 2s are and your answer is 2 by 9. That's clearly understood. Done. Okay. Then so first question done. Right. Next B. Right. So for B, what do I do is, let's see this B question. Here we have a B question. Okay. Now B question says what? One blue ball and one yellow ball. So probability 1 blue and 1 yellow. Probability 1 blue. It is not said first blue. 1 blue and 1 yellow. Now how can this happen? This can happen as probability of blue first and yellow next, right? So from blue, or do you understand this? Or probability of yellow first and then blue, right? So one blue and one yellow done. Do you understand this? Wherever you have and multiply, wherever you have or add. Do you understand this? The simple rule. So P of B1 into P of Y2. Which Y2? Be careful. Which Y2? It has to be B1 wala Y2, right? Plus P of Y1. Then the B2 has to be of this thing, right? Since conditional probability has not been explained, I cannot right now just write B2 by Y1. It would just, you would somehow be confused with that particular notation, right? So with the tree diagram, I'm just mentioning it this way so that you understand it in the easiest possible manner. So here you have B1, so that's a 3 by 10 to start with, and yellow of that branch. B1 में yellow का branch, that is 2 by 9. I hope that's understood. Next comes plus, right? The next comes a Y1. Y1 is 2 by 10, 2 by 10, and then B2, blue of that branch. That branch blue is 3 by 9. So that's done. You can just simplify the stuff. You can simplify the stuff. 3 3s, right, and 2 5s. Similarly, 2 5s and 3 3s, right? So this is 1 by 15 plus 1 by 15. That's 2 by 15. I hope that's clearly understood, right? Okay. Next comes as two yellow balls and two balls of the same color. I'll directly go for two balls of the same color. That makes more sense, right? That will cover your yellow part also, right? So here I go for a change. Yeah, I suppose that much is enough for me. Yeah. So now the probability, the next part, the probability. So here what do I have is the next part, that is D part, which says probability two balls of same color. Now try understanding. Two balls of the same color means both balls can be two red. Okay, I'll write it more easily so that you understand it. Okay, that means a red one and a red two, or right? Understanding this. Red 1 and red 2, or what? Blue 1 and blue 2, or what? Or yellow 1 and yellow 2. Right? Again, the same simplest of understanding. Right? P of R1 and R2 of the same branch. Please don't make mistake. P of B1 and B2 of the same branch. I'm emphasizing on things. Or means plus P of Y1 and P of Y2 of the same branch. Do you understand this? Clear? So P of R1, when I say it's 5 by 10, do you understand this? Into P of R2 of the same branch is 4 by 9. Right? Again, it's a conditional probability. Plus P of B1, it's 3 by 10. Done into P of B2, it's a 2 by 9. See the branch, you'll understand it, right? Plus, you understand this? See this branch here, right? So B1 3 by 10, B2 2 by 9. I hope understood, right? The next one, Y2 2 by 10, 2 by 10 into Y2 of the same branch. See this, Y2 of the same branch. You understand this? Y2 of the same branch. It's a 1 by 9. It's 1 by 9. Right? You can simplify this stuff and you have the answer according, right? So what can I write is, I can simplify this stuff here itself. So this is 2 and again 2 2s. So you have 2 by 9. Then here I can have 3 3s and 2 5s. Right, so I have 1 by 15, and last is I can have 2 5s, so 1 by 45, simplified as 45 LCM. 9 5s, so this becomes a 10, 15 3s, so this becomes 3, and this is 1. So this is 14 by 45. That's understood, I hope. Clear with the understanding, so that sum gets solved out. This is the way we go ahead with the tree diagrams. Right, so this is a basic understanding as to how do you solve the problems, right? So we have solved a replaced, not replaced, right? So there are many more problems which you can go for to understand things. Done. 6 marbles, 4 blue. This seems to be easier one. You can manage it easily. Just a hint for you people: if you don't not able to solve it, just post me the things. Accordingly, I'll work out. At least one red marble. Check this, right? So probability at least one red marble. Just understand this. At least one red marble means what? It means probability of one marble, or probability of two red, one red, or two red, or three red, or four red, till six red. Now this is crazy. You need to have a better method for this. You need to have a better method for this. Do you understand this? So what do you do is you say 1 minus probability no red. Now try understanding when you don't have any red, right? Probability no red. So when you remove that probability, what remains is all the probability where you have at least one red. Do you understand this? So what you need to do here is 1 minus whatever is your answer of C, this part, whatever is your answer of this part, C, right? You need to subtract that. I hope that's clearly understood. 1 minus C will give you the answer for D. I hope that's clearly understood. Done. So this is the way you work out for this particular question. Done. Okay. Now the next one, the dice. Here you have it. Here you have it, right? A dice. Now this is a, I won't say very confusing, but thoda sa, so that just understand it. Here I put it. Yeah. Okay. So a die has it's six faced marked as 0, 3 are ones, and 2 are sixes. Two of these dice are thrown. Now there are two dice, and two of these dice are thrown together, and the total score is recorded. Okay, fine. Draw the tree diagram. Draw the tree diagram. So what would be the tree diagram? 0, 1, 1, 1, 1, 6, 6. That way? No, it has to be this way. Simple. You can get 0, or you can get 1, or you can get 6. What is the probability of getting 0? See, actually nothing of that kind has been asked as of now. But you can find what is the probability of getting 0. What is the probability of getting 1? What is the probability of getting 6? So probability of getting 0 is how many? It is only once out of 6. Probability of getting 1 is how many? Is how many? It's 3 by 6. Probability of getting a 6 is how many? It is 2 by 6. Do you understand this? And further this branch goes ahead. Further this branch goes ahead. Right, so here is the branch. Okay, now this branch will have again 3. Do you understand this? Because second dice is again thrown. So again 3. I hope understood. Right, so let me just have a better line here. Okay, so again 0, 1 and 6. Again 0, 1 and 6. Right, again 0, 1 and 6. I hope that's clearly understood, right? I've drawn branches so that I can accommodate the writing part and clearly understood. Okay, fine. Now, what do they want, by the way? They said they want draw how many different totals are possible. Now, just check how many different possibilities, right? You can get 0 here, you can get 0 here. So, your total is 0. So, total A. What are the totals that you can get? So, what are the totals that you can get? You get 0 plus 0, so that's a 0. You understanding this? Next, 0 plus 0. Next is 0 plus 1. You understand? You're getting 0 here. So 0 plus 1. You're getting 1. Do you understand me? Right? Next is you get 0 plus 6. So that's 6. Right? Next is 1 plus 0. So 1 I have already written. Next is 1 plus 1. So that's 2. Right? Next is 1 plus 6. So that's 7. Right? Next is 6 plus 0. I've already written 6 plus 1. 7 already written 6 plus 6. So that's 12. So I hope that is clearly understood. So these are all the possibilities. So how many different totals? So how many different totals you get? 1, 2, 3, 4, 5, 6. So there are 6 different totals that you get. Right? Now, what is the probability of obtaining a total 7? Now, how can you obtain 7? Just check this part. How can you obtain 7? You can get 7 in these two ways. This is one of the branch. I'll just change the color for you people to understand. Here I have it. Here you can get this way 7, 1 plus 6, or you can get 6 plus 1. This branch 6 plus 1, 7. Do you understand this? So you just have to add this probabilities. That's all, right? So I'll just talk about those probabilities. So what is the probability of 6 here? Since it's the second die, this is first die, right? This is second die. Second die is has nothing to do with this thing. They are mutually exclusive as well as independent. Try understanding, because again, I won't say completely mutually exclusive. My bad. I would say they are independent. One event has to do nothing with the other. So probability of getting 6 is again the same. Do you understand? It's 2 by 6. Probability of getting 1 here is same as we got in the first. Probability of 1 is 3 by 6. Do you understand me? Clear? So now just add their probabilities. So B part. B part says what? Probability a total 7. That is probability 6, 1 first and 6, or probability 6 first and 1. So probability of 1 and then a 6, or probability of 6 and means multiplication. I'll just remove this, yeah, and probability of 1, right? So what is probability of 1 anyway? It is 3 by 6. What is probability of 6? Probability of 6 that I got is 2 by 6, and the same thing will repeat, and I have to repeat, right? So whenever I have a plus a, I multiply by 2. A smarter way of doing it, right? So 3 2s are 6, 1 6 goes away, 2 3s are, so your answer is 1 by 3. Did you understand this? I hope that is clearly understood. Was a video for you people to understand things.